All right, welcome back, guys. And today we'll be discussing the further cases about deletion in a red black tree. So, in order to understand the initial concept about deletion in red black tree, you can please watch my previous videos. The link is already there in the description. All right. Okay, so in this case, we will consider that particular aspect when the node to be deleted is an internal node with two children. All right, so over here, I already have prepared a red black tree, which is already in compliance with all the properties of the RB tree. All right, whether it is about two adjacent red nodes violation, or is it about that the root should be black and the black height and all that things. So we need to consider that the tree, whatever I will be giving as an example, are already the red black tree. Okay. Now let us say that I want to delete the node 30. So we already seen in the previous video that we can delete a node only when it is at the leafmost position. But what happens if the node is at the internal node position? Then we need to perform replacements. If the node has only one child, as we saw in the previous video, then we can go with replacement with that particular child. But definitely color constraint needs to be taken care of. All right. Now, in this case, the node which is to be deleted is 30. Okay, 30 is red in color. Fair enough, fine. Now, 30 is located at an internal node position. So we cannot delete 30, with that particular position. So what is needed? The thing is that we need to replace 30, but 30 has children at both the two places. 30 had children at the left position also, and the children at the rightmost position also, right? So let us assume that we are selecting the rightmost in order successor. So in that case, what happens when I select the right subtree? What is the right subtree? This is the right subtree. Okay, this is the right subtree of node 30. So what is in order successor? In order successor is the smallest element of the right subtree. And which is that smallest element? That is node 38. So in that case, I need to make a replacement with my right smallest element of the right subtree. So if I do that, my tree will now become in such a manner that, let me change the color first, okay, for convenience purposes. So it will be 10, and then I will be having 5, 2, and 9. It's all good. And then I will be having this house is already red in color, okay. And then I will be 25 was already there. Then I have 40, and then again I had, all right, this is 30 and this is 38. So if I just give a glimpse of you, what happens? That 38, node number 38, which is the smallest element of the right subtree, that was also red in color. And the node which we are supposed to delete right now, node 30, that was also red in color. So any which ways replacement does not changes the color of the node. So both of them are replaced with one another. And finally, we have this interpretation. So now when 30 is at the leaf position, now we can delete node 30 and that will not have any violation. All right. So let's now consider another aspect of it, that the another aspect is that case of double black nodes. All right. Now, double black node is a very special case. In this case, what happens that we cannot delete a black node. Why we cannot delete a black node? Because deletion of a black node affects the black height in a red black tree. All right. So that is one of the most prominent things to be considered. But let us take the example into consideration that what will happen, and what sort of cases am I talking about. So the last case for deletion is the case of double black. Let me tell you what this double black actually means. That let me say that I have, node 10, which is black in color. Then I have node 5, which is again black in color. Let me take node 20, which is red in color. Let me take node 15, which is black in color. And let me take node 30, which is again black in color. Now, if I say that I want to delete node 20, and for convenience purposes, let me give 20 a red color only. Okay, so I want to delete this node 20. Now, what happens, guys? Can I delete 20 with its current location? No, I cannot delete node 20 with its current location. Why? Because right now 20 is an internal node. So I cannot delete 20 right now. 20 has two children. At the leftmost position, I have 15. At the rightmost position, I have 30. Both these two are black in color. So even if I go for replacement, what will happen? I can replace 20 with either 15 and I can replace 20 with either 30. But even then, will I be able to delete node 20? In that case, what will happen, guys? That 20 will come at the leaf position. But even if I have a scenario like this, that 30 comes here and 20 comes here, so the color does not changes now while replacement. So 20, even if I change, I replace 20 with the rightmost, rightmost element. So the color of 20, the place where node 20 is located, that will still be black in color. And the properties of deletion states that I cannot delete a node which is black in color. So question various times occurs to, our mind that okay, a node can be deleted when it is at a leaf position, plus a node can only be deleted when it is red in color. So why does black color affects a red black tree? Because one of the most important properties of red black trees is the concept of black height. Guys, if you want to understand the concept of black height, go and please watch my previous videos. The link for all the videos is already given in the description link. Okay, so in that case, it is not, convenient that we just go and delete our delete the particular node which is black in color. So in that case, we cannot delete that node. Now, what are the other cases that can happen? So in that, with that particular respect, I need to tell you certain kind of properties, and then I will explain with the help of an example what happens with the case of double black. In the case of double black, we need to take various conditions into, into reality. A, deletion of black node is not permissible because it can affect the black height of a red black tree. Fine. Secondly, we need to check if the root is double black. If the root is double black, I mean, if it is black all the ways, for instance, in this particular example, the root is not double black. Why? Because I have a black node and then I have a red node. And if it is only about 5, it would have been the case. But right now, we don't have a double black with respect to root node. Why? Because I'm focusing on deletion of node 20 right now. Okay. So if the root is double black, then we can just remove the double black and keep one black node. So that is the simplest possible case. If the root is having black configuration, or for in this case, if I consider that even if I wanted to delete node 5, then what happens? The root node, which is 10, is already black in color, and the node to be deleted 5, that is already black in color. So in that case, even if I say that root node 10 was double black, then I can simply remove this double black and can keep one simple black. Okay, so this is the consideration and this is the simplest possible resolution. But if the root is not double black, for any other node that is double black, we need to check the color of the sibling. Do you guys remember that in the insertion videos of red black tree, I told you about, we used to check the color of the uncle. And for all those doubts, guys, please go and watch my previous videos. But anyways, if the root is not double black and any other node which is double black, what do we need to do? We need to check the color of the sibling, that if the sibling of the double black node is black in color or both its children are also black, then we need to take a decision. All right. So in this case, the double black node gives one black color to its parent, and seeing this, the sibling node, which is already black, becomes angry and hence changes its color to red. But don't worry, guys, in order to explain these properties in reality with example, stay tuned for my next video and I will explain all of this step by step to you guys. See you in next video. Thank you.